page 10 of quadratics. This is an interesting page because it is completing the square, and completing the square is sometimes asked on the IB exam, and if you know how to complete the square, then you will get those 1 or 2 points specifically about completing the square. But the thing is, a lot of times instead of asking you to do a completing the square problem, they might say complete the square or otherwise do what is asked, which is basically put it in vertex form, something like that. So sometimes they don't even hold back any points. You may do completing the square by other methods. Occasionally there might be 1 or 2 points dedicated just to doing specifically completing the square. But let's say that you still don't know how to complete the square after having learned it a couple times up until now. I don't think it's worth learning completing the square, because if you've learned it twice and you don't know it today, even if you learn it today, you're not going to know it in May of 2021 or whatever. So I'm going to show it once again here, but I'm also going to show you an alternative way to kind of fake your way through completing the square and get most of the points that they're giving. Okay? All right. Write the following quadratics in the form by completing the square. And notice this is vertex form, right? So vertex form means that you're using the HK form. And one of the ways to get into the HK form is by completing the square, but there's other ways to do it. So first we'll do it with completing the square, okay? So we're going to take this and we're going to complete the square. First thing that you need to do to complete the square is you need to find a magic number. The magic number is the number that you wish was here instead of the 3. Okay, so let's do this. We're going to rewrite it, except this time we're going to leave a space between the 2x and the 3, and then we're going to figure out what number would we really like to be there so that we could complete the square. And the way we do that is we take the b value here, -2, and we divide it by 2 and we square it. So -2 divided by 2 is -1, and if we square it, it's going to be +1. So that is our value that we're going to use for the magic number. And so I'm going to write it in blue, okay, just so that we can see the magic number is +1. And you can't just simply add +1 here. If you do, that's going to ruin the equation, right? But one thing that you can do is you could add 0. How do we add 0 in this case? We can add 1 and then we can subtract 1 immediately. If we add 1 and we subtract 1 immediately, that's the same thing as adding 0, which is doing nothing. And even though you might say, well, if you're doing nothing, why do you even do it? But now we're going to go to the next step, and maybe you'll see why completing the square involves finding this magic number. Okay, so now if I just separate this out, and I include the +1, but I keep the -1 outside of the parentheses, you can see that I could factor x squared minus 2x plus 1 into x minus 1 times x minus 1. And if I do that, then I'm left with x minus 1 quantity squared minus 1 plus 3, right? -1 plus 3. So if I was to rewrite this simplified, I would say, okay, my new HK form is x minus 1 squared plus 2. Because I added the 3 to the -1, I ended up with plus 2. What's my vertex? My vertex is going to be +1, +2, right? Okay. So I have found the vertex. I could draw a sketch. I got 1, 2. 1, 2 is right there. It is an a value of 1, so that means it basically goes up at the rate of 1, 1, 2, 4, right? And I can check also that the c value is 3, so that means that it crosses the x value or the y-axis at 3, and it really does. Okay. Ooh. Okay. So that's about right. Now I'm going to show you a couple other ways, okay? By the way, that was an easy completing the square because the a value is indeed 1, okay? Now, another way you could do it, if they don't specifically ask you to use vertex form, or to use completing the square, you could just find the vertex, and we already know how to find the vertex. The way you find the vertex is you find the axis symmetry, which is negative b over 2a, which is negative 5 over 2 times 1, negative 5 halves, which is negative 2.5, right? And then you could find the y value just by taking negative 5 halves and putting it into this original equation. So that would be, for example, negative 2.5 quantity squared, because this is negative 2.5, plus 5 times negative 2.5 minus 2. Okay, so let's see, 2.5 times 2.5 is 6.25. So 6.25. 2.5 times 5 is 12.5 minus 12.5 minus 2. So 6.25 minus 12.5 is minus 6.25, minus 2 is minus 8.25. So in this case, our vertex is going to be negative 2.5 times negative 8.25. So I found the vertex. Now, one last thing is we need to write it in vertex form, which means we write y equals x minus the x coordinate, which would be negative 2.5. So minus negative 2.5 would be plus 2.5 squared, and then I would put the y coordinate of the vertex, which is minus 8.25. Okay, and if I was going to graph that, I would put points at negative 2.5, negative 8.25, so it would be about here. And again, this is a, what do you call it, a parent function parabola. So it's just, you know, about the regular, oops, that's not good. It's like a regular width parabola, kind of like that. C, x squared minus 4x. So, again, we have two methods. One is by completing the square. The other is by finding the vertex using negative b over 2a. Those are two ways of finding the vertex. Another way is with the calculator, right? This one here is pretty easy because our b value is negative 4 and there's no c value. So I'm going to divide negative 4 by 2. I get negative 2. I square negative 2. And remember, when I square negative 2, it's negative 2 times negative 2, so the negative sign disappears. So the magic number is always a positive number, okay? So I'm going to put plus 4 here, and then I'm going to immediately subtract it out, minus 4. Okay, and then I'm going to group x squared minus 4x plus 4 together, and then I'm going to factor that, and then it factors, of course, into a perfect square, x minus 2 quantity squared minus 4. So if you are factoring and it is not a perfect square, then obviously you're doing something wrong. So here the vertex is 2, 4. And if we want to graph that, it would be, the vertex would be like here, 2, 4. And it is a parabola that opens up because the a value is 1. Oops. Okay, about like that. So we did that one by completing the square, but it was a quite easy one. And then we'll go back and, for example, this one we'll just do with negative b over 2a, okay? So in this one, negative 6 is the b, and a is 1. So negative b over 2a would be negative 6 over 2, which is equal to 3 halves. So my vertex x value is going to be 3 halves. I'm sorry, not 3 halves. 3, right? 3. Positive 3. And then if I put the x equals 3 into this equation, I'm going to get 9 minus 18 plus 5, which is equal to negative 9 plus 5, which is negative 4. So the y value of the vertex would be negative 4. So my vertex turns out to be 3, negative 4. And if I graph that, I would put the vertex at 3, negative 4. It'd be right there. And then it'll be a parabola that opens up. It'll be a parent function parabola that goes up 1, 1, 2, 4. So there we go. Okay. And last of all, we got x squared minus 5x plus 1. This looks like a mess if we wanted to do it with completing the square. I'm just going to do it with negative b over 2a, okay? The reason why I say it's going to be a mess is because negative 5 is an odd number. If we found the magic number by dividing by 2 and squaring it, guess what? You would get a even more terrible fraction for your magic number. So instead of doing that, I'm just going to use x equals negative b over 2a, okay? So that would be negative 5 divided by 2 because the a value is 1. So that's equal to 2.5. Okay, and then if I wanted to find the y value, I would put the 2.5 into x squared minus 5x plus 1. That would give me y equals 2.5 squared, which is 6.25, minus 5 times 2.5, which gives me minus 12.5. And then plus 1. And so that would be negative 6.25 plus 1, which would be negative 5.25. And so my vertex is going to be at 2.5, negative 5.25, which is right there. And my parabola has an a value of positive 1, so it's just going to open up just like a regular width parabola there. Okay? Well, I forgot one more thing. When you complete the square, one of the things you end up with is the vertex form, not just the vertex. So when I do find the vertex form, when I find the vertex 3, negative 4, I do also need to write the vertex form equation. And the only question is, what do I put for a? Well, the a value you're going to put is the same a value you have here. So if a is 1, we leave it as 1 also. Okay? And so what about for this last one? For this last one, it's going to be x minus 2.5 squared minus 5.25. Okay? And that's it for this page, right? Yeah, that's it for page 10.